All right, let's see how this works. I have a microphone here. It's actually a microphone array, so it's using 4 different microphones to filter out sound. Kind of the idea is that I should get much clearer sound when I'm using this microphone. Anyway, it's a new day and it's time to add a new component into my library, and this time it's going to be BC832 Bluetooth Low Energy module. It's a tiny module that features an M4 actually. It's a Nordic NRF 52832 with ARM Cortex M4F, so it's pretty powerful for being this small, and it has basically everything necessary for establishing the Bluetooth lower energy connection. So the footprint looks like this, but I'm gonna start with a symbol first, and we have a bunch of pins here, so we're gonna transfer them into KiCad. I'm gonna add a new symbol, and I'm gonna pick the library. We can go with that one, BC832, and let's make this a little bit smaller. And then I'm gonna use this this pin wizard. So let's see how many pins we have. We have a bunch of pins that go to the BGA directly, so we don't have any numbers, but we should be able to just copy this. Okay, so the idea is I could do this with like OpenOffice Calc, just paste in there and then modify the list, but I'm gonna do it in Emacs, so I can show you a little bit of macro usage in Emacs. But first, I'm gonna go. Actually, let's paste this first here. So, let's see. That isn't very good. Can I not copy this table? Really? Interesting. Let's try it. It's just one big line. Well, that wasn't very practical. Let's see. Am I like copying this wrong or something? I should be able to copy this. Okay, maybe I need to select the whole thing. This looks definitely like a table. Nope. Interesting. Okay. I guess we'll have to do this manually. Is there anything I could go after, like a number maybe? Use that as a starting of the line and split it by numbers. Let's see, what could I do here? I mean, this is a total mess. I can't really go after anything here because there are numbers everywhere. There is nothing that I could use as a marker for starting off a line. Okay, let's see. I'll have to do like this then. I'm gonna actually use this wizard. And number 1. set the size later. Two is P20 and 3 is VD iron, 4 is VD clock, 5 is P18, 6 is P13, 7 is P11, 8 is P12, 9 is P03 analog input number 1, 10 is P21, reset, 11 P00 crystal 1, 12 P01 crystal 2. So I'm going to be taking care of the electrical type after I've entered all the pins, because I just sort of want to get this part done first, and then I can look at the text that I have here and just set the proper type of the pins. So 13 is P02, analog input 0. 14 is P27, CL. 15 is P26. And then when once I'm done with both the symbol and the footprint, I'll just go over it quickly, make sure all the numbers are correct, and then once the schematic is done, then I go through all the components in more detail and actually check all the electrical levels on each pin, which would be sort of the final review of this component before it can be marked as verified. Let's see, SDA 16 is VDD, 17 does not exist, it's P28, which is on pad number A1, A2 is P17, A3 is P04, A4 is P06, and A5 is P08, B1, P25, B2. These pads are directly connected to the BGA pins of the NRF chip, so you actually can have direct access to every single signal on the BGA on the chip itself. P29, that was P29. B3 is P31 DCC. B4 is P05. B5 is P07. C1 P24. C2 P22. C3 P30. Let's see. Yeah. C4 is P15 and C5 is P09 and D1 is P23, P2 P19, D3 P16, D4 P14 and D5 P10. All right, then we can go over all of the pins here. P20 GPIO bidirectional. This one is GPIO. Yeah. set that one bidirectional. This one is an input. Because this is from the debug. This is for uploading the firmware and the serial debugger port. P18 is GPIO, so that will be bidirectional. That one is bidirectional. That one is also bidirectional. I don't think at the moment KiCad has any any significantly good DRC checker. But hopefully in the future KiCad will have a very good DRC checker, in which case having the electrical type set would be quite useful. But even the basic one can detect things like if you connect two pins that are outputs together, it will generate an error so that you can fix that fault, because you don't want to have two pins that drive each other. Let's see. Although I do agree that, like with bidirectional pins, actually I think it generates an error for bidirectional pins as well. But I'm not sure. Anyway, analog input, that's a GPIO. It gets a bit tricky for the pins that can be both like just one type and then a GPIO, depending on how you configure them. But then I would set it to a GPIO, of course, because that will warn in a larger number of cases. So reset is an input, I guess. Yeah, that's configured as reset. Crystal, let's make that bidirectional. I wonder if this module actually has a the main clock crystal on the module, because this is only for the real-time clock. Bidirectional, bidirectional. And then we have bidirectional, power input, P28 GPIO. Yeah. My lens is sleeping on my eye, so it's getting this weird effects in the field of view when it kind of gets old, when it gets like stuck. Let's see. This one is a bidirectional A3. Yeah. GPIO, 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 DCC. Let's make this bidirectional for now. This is also inductor connection. NFC antenna. Let's make this one bidirectional. P15, P9. So P9 would be, yeah, it's basically a GPIO. So bidirectional, bidirectional, and bidirectional. Yeah. Okay. Cool. Let's go to the component, and we have all the pins here. So I'm going to be moving the pins into place. Let's put this one there. Actually, I'm going to also change the default size. I like to set my pins to 2.54. because I kind of find that setting them to 2.54 looks really nice with all the other components around. Otherwise they're too long when they're 5 millimeter. And then I can just press M here and just select one. So right now, let's just I wonder if there is any. Oh, actually, I'm going to do like this. Global push pin size to everything. This is very useful. You can change the size on one pin and then just push the size to all the other pins. Let's have a look at the data sheet here. Okay, I'm gonna just continue moving them out. I like to place the ground pins at the bottom, so I can just stick a ground symbol on them. Let's actually group these ones together, because these ones are the BGA pins on the bottom of the footprint, whereas these ones are available on the sides of the footprint. Analog in. And it's good, like when you place the pins, for example, for a crystal, it's good to leave some space between them because that makes the schematic look better. If you just place them like this, then you will always have like two wires coming in like out here and then going up and then fitting to the crystal. If you put a little bit of space here, you can just wire the crystal directly. It just looks nicer. So analog 0, analog 1, bidirectional SCL. Let's move these ones. Let's move this one also here. Then we have these two. SCL, SDA, VDD. I usually put VDD at the top. Like that. And then all of these VGA pins. They basically go, just place them close to each other. Actually, they could actually go on this side. I wonder if I can somehow do some alignment here. Maybe there is some alignment trick I could do. to distribute the pins. Is there anything like that in the symbol editor? I guess not. Okay. And by the way, you will be able to find the library with lots of other components as well. There's going to be a link in the description of this video, so you can get it from GitHub if you want. Of course, I think that libraries in particular, they tend to be more like a personal preference, because I pick some components, I put the manufacturer number on them, and then I can reuse them, and basically it makes designs easier. But at the same time, the components that I use may very well not be the components you want to use for your design, like in terms of manufacturer number. Like you can have the same component from many different manufacturers, different numbers, slightly different prices maybe. Like that. So we can actually move this one here. Let's see. Place them here. Can we mirror this? Oh. Let's see. Yeah, good. That's what I wanted. And with Y we do like that. Nice. And then these ones will go, ground will go at the bottom, and these ones will just go like this. So mirror around X, A, B, and C. And D. All right. Place them here. Place the ground at the bottom, and then we can draw just the box around like this. Okay. Okay, this will do. I just want to go over the pins and just check them at least once before I save the component. Let's go to the list of all the pins here. So we got ground, P20, SVDI, SVD clock, 4, P18, 13, 11, 12 to 8, P03, P21, 10, 11, P00, 12, P01, 13, P02, 14, P27, 26, VDD 28 goes to A1, A2, P17, A3, P4, A4, P6, A5, P8, 25, 29, 31, 25, 29, 31, 0507, 0507, 24, 22, 30, 15, 09, 23, 16, 14, 10, 19, 16, 14, 10, 55. Okay, that looks good. So the next thing we're going to do is we're going to go to the settings here, and we're going to add a new field here, which we're going to call MPN. MPN, not MPB or anything similar. And then I will go to Mouser in this case. Let's see. Where is the... Oh, there I have it. Good. And I'll just take the manufacturer number. So in this case, it's BC832. And I'm going to type it there. And then I'm going to save this library. Let's see. I'm going to save the component in the library, and then I'm going to run my Python script, which you will also be able to find in the video description, which will go through the library and basically update this component with things like the price, lots of different parameters that it can get directly from Mouser. And to do that, I will run, let's see, I will run the script like this. So I have it, I'm going to push the latest version into my KiCad library utils Git repository. And at the moment, this one is missing footprint. That will be the next step to add the footprint. And you can see here that it has gotten the availability. There is 611 in stock, description, life cycle, and the price. So all of this is very useful information, which is now directly saved in the symbol. So if we close this one, and let me just pop this up again. And if we open it now, we can see that all of the fields have been added by the script. So everything is in here. And this makes it very simple to generate very nice BOM lists later. And what I usually do also is I update all the fields here in the library, and then I just execute update fields from libraries on the schematic. So I get the latest values for all these fields. And then the symbol is complete, and it's in my library. So thanks for watching, and see you next time. I wonder how well this microphone is working. This is actually one of these microphone arrays that has a bunch of LEDs on them. And it can actually detect like where the sound is coming from, but I don't have any enclosure for it, so it's just sort of suspended in there. Okay, let's see.